Hi guys, if you're tuning in, I'm going to be going over a division problem and I'm going to be showing you two different ways to solve this division problem. We've been talking about place value strategies in class, one of them being the area model, also known as the box method, and the other one is partial quotients, also known as the big seven. So we're going to start off by doing 975 divided by 5 in area model. I'm going to do the same problem, 975 divided by 5, using the partial quotient method so you can see them side by side, and then that way you can decide which one works better for you personally. And that's the one that you're going to want to use so that you know how to divide at a 4th grade level. So the first thing that we do in class when we're looking at 975 divided by 5 and how to solve that is we look at the divisor, or the number that we're multiplying by. And we're going to take this divisor, and before we start doing anything at all, what we're going to start doing is getting into the habit of writing tic-tacs out. The point of these tic-tacs, if your child hasn't told you yet, is so that you can have a nice organized area where you have your first 9 multiples of your divisor in the same order every time. That way, no matter where you look at the square, you know which multiple of which divisor a certain number is. So let's start with 5 so you can actually see what I'm talking about with these tic-tacs. If we have 5, 10, 15, 20, 25, 30, 35, 40, and 45, then we're taking pretty much all of the work out of dividing. So that's always the first multiple in the first box. Top right corner, always the 3rd multiple. Bottom right corner is always the 9th multiple, since these are in rows and columns of 3. And the bottom left is always a 7th. Always a 4th, always a 6th. So it doesn't matter where you're looking. The middle is always the 5th multiple. You can quickly glance. And even if you don't remember that, you can just count. So if you're looking for the 30 and you don't know that that's always going to be the 6th box no matter what, you can go 1, 2, 3, 4, 5, 6, left to right, top to bottom. And it's going to help you take a lot of the guessing out of dividing in general. So now that we know our multiples of 5, we can actually break up division problems into basic facts, basic multiplication facts. So, well, first of all, before we start solving anything, also we need to estimate. That way we know if our answer that we come up with is going to be reasonable or not. So we're looking for a compatible number. If we look at the number 9 here, we want to see how many times 5 can go into 9, or just the closest multiple to 9 that we can get by using the divisor of 5. So if we look at here, how close can we get to 9? 10 is right there. So we're going to use 10 as a compatible number, meaning a number that 5 can go into since it can't go into 9. So it's compatible. We're going to use 10 to get a close estimate. And then that 9 is in the hundreds place, so that 10 also needs to be in the hundreds place. So we're going to replace the 7 with a 0, and then also we're going to place that 5 with a 0. So we're going to think, instead of 975, we're going to think 1,000 divided by 5 or 1,000 divided by 5, so that we can have an estimate, and it's just easier to do that mental math of dividing by tens and hundreds and thousands, just like we used to multiply during that unit of by tens, hundreds, and thousands. So we got 10 divided by 5 is 2, and it's in the hundreds place, so 200. Our estimate is 200. That's where we want our answer to be close to be once we get our quotient. So now that we have our tic-tac, we got all of our multiples listed out really nicely. We have our estimate, so we know kind of around where we want to be. I'm going to first show you what the area model is going to look like when we're using our division. So a lot of people call this the box method also. I always call it the area model, mainly because it looks exactly like the area of a rectangle, which essentially that's what it is. So when you're doing the area model for division, we set it up a little bit differently than multiplication. For this one, we're going to start with a box. And then on the left side of that box, we're going to plug our divisor in. So here's our 5. And again, the divisor is what we're multiplying by. The dividend is what we're starting with and what we want to divide. So that number is going to start at the top of our first box, but not on top of it like multiplication. It's going to be inside of it. So 975. We're going to start looking at our 5 here, and we're going to see how many times that 5 can go into 9 without going over, because division is repeated subtraction. So we want to see how many groups of 5 we can take away from 975 all at once. So first, we're going to look and see 9. Is there a 9 on our tic-tac? If not, then we want to find the very closest number to 9 that we can get without going over the number 9. So 9 is going to be located between the 5 and the 10. Since 10 is larger than 9, we're going to choose the 5 as our first amount that we can take out of the 975. So we have a 5 here. And the 5 is the first multiple of our 5. So we need to put a 1 on top of our box right where that 9 is, because that's what we were looking at. So when we do 1 times 5, we get to 5. So we can already take 500 groups out by multiplying that 5 by 100. So the 100 needs to go up here because 100 times 5 gets us to 500, and we can now subtract that away from 975. So we're left with our 5, 7, and then 9 minus 5 is 4. Once we have this number down here after we've subtracted, we're going to add on to our box. And every time we add on to our box, we need to put an addition sign because we are adding to our box. So this 475 needs to be transferred up to the top of the next box because that's going to be our new starting point. So we have 475. And we're going to start all over with that step of looking at that very first digit and seeing how many times 5 can go into the first digit in this number. So let's look at 4. Do you see 4 on your 5 tic-tacs? If not, that means that we need to look for the closest multiple of 4 without going over. In this case, the first multiple is 5, and that's already larger than 4. So we cannot take any groups of 5 out of 4. So we just need to look at the second digit here. Now we have 47. So now if we don't see 47 on our tic-tacs, we are going to look for the closest multiple to 47 without going over. So we see 45 right here. If we add another group of 5 to that, we go to 50. So we know that 45 is the smallest multiple that's closest to 47. So we're going to use 45. And since that's the 9th multiple of 5, then we're going to put the 9 above the 7. It's important that you write it above the 7 and not above the 4 because that's going to mess up your zeros, which will throw your whole answer off. So if you are looking at a 2-digit number, you've got to make sure that when you're putting these numbers up, that you're lining them up by the correct place value. So we put our 9 up above the 7 since that's our tens place. And then 9 times 5 is 45, but it's in the tens place. So let's add our 0 here. And then our 0 place value holder up top. So 90 times 50 is 45 tens, which is 450. So once we do that, we are able to subtract 450 away from 475. So when we do that, we are left with 5 right here. And then 7 minus 5 is 2. And then 4 minus 4 is nothing. So we're getting down to a lot smaller numbers, which is really good. So we do still have some that we can take out. So we're going to draw another box. Since we just added another box, we're going to put a addition symbol in between so that we can continue to add. As we start lining these numbers up here, those are all parts of our quotient, partial quotients. All right, so we have our 25 on the bottom of this box, meaning that we are going to put it up to the top of the next box so that we can restart all over again. So we'll put 25 up here, and then we're going to look at our tic tac and see if we can find 25 on our tic tac. If not, we'll find the closest multiple to it that's lower than it. So we do have 25 directly on our tic tac, which is always really nice, especially when it's going to round out the number and make it so that it goes in evenly, so we don't have to worry about any remainders. So since 5 can go directly into 25 and it's in the ones place, we don't have to worry about zeros. We're just going to put that 5, since it is the 5th multiple right in the middle of our tic tac, right up on top of that last box, because that's our last partial quotient. We know that because when we subtract out, we're left with 0, which tells us that there's no remainder. If that was not a 0 and it was any number that is less than the divisor, meaning that you cannot take not even one group of the divisor out, then that's how you know that you have a remainder, because you cannot do anything else with it. So we do have a 0, so that tells us we have no remainder. So what we're going to do is take all of our partial quotients and add them together for the whole quotient. So we have 100 plus 90 and plus 5, and we're going to add all these together to get 195. We're not done yet, because we still want to double check and make sure that our quotient here is close enough to our estimate to be reasonable. So we're looking for place value or just relatively being close and in the ballpark. So if it's like, 10,000 off, we're probably just looking at the wrong place value and stuff like that. So it just gives us another opportunity to double check when we need to, but not to waste our time if we don't. So our estimate here is 200, and our quotient that we came up with was 195. So that's really close. I like that answer. I think it's a reasonable answer. So what I'm going to do now is check my work. We talked today a lot about inverse operations and how we check division with multiplication and just kind of switching the order around. So we're going to take our quotient and multiply it by our divisor. And then if we get the dividend that we started off with in the beginning, then we're good. If we did have a remainder, we would have to add that to the end. This problem doesn't apply to that, but we'll have plenty of examples in class where you guys can get a lot of practice with that. So we're going to take 195 and multiply it by 5. Okay, we'll start at the ones place and we do 5 times 5. If I don't remember what 5 times 5 is, here we go. I just go to the 5th box. 5, 1, 2, 3, 4, 5. That's 25. There you go. Look at that. You already did the checking math as well. So we can put our 2 up top above the 10s, and then our 5 we will carry down to the 1s, and then go back and multiply that by every single digit on the top. So we have 5 times 9 equals 45, and then you're going to add what's left over. That's 2. So 45, 46, 47. And then we have our 5 times 1, which is 5, and then add another 4 onto that, and we have 975. So now we just check and see, is 975 the same as what we started with? Yay! We got it right. So woohoo! And we know for a fact we got it right, and we can be extra confident about that answer. That's the area model, aka box method. I'm going to quickly go through the partial quotients way of doing the same problem, just so you can kind of see how it matches and how it's partial quotients is essentially the same thing as the area model, just without drawing the box. So I'm going to try to keep these colors in the same order so you can kind of see what matches with what, if I can. But let's see. We're going to start our division problem out with the little house thingy. I don't know what that symbol is called, but we take our dividend and write it down. And then the symbol for division when we're doing partial quotients, it's literally kind of like a house. You put what you're starting off with in the house, and then the divisor is on the outside. Okay, so the big 7 gets its name because it looks like a big 7. And then there's a nice and organized way of writing down. Oh, maybe I'll do that in orange. Your partial quotients. When you start with this one, it is very important for you to match up place values when you're writing your partial quotients. That way they're already set up for you when you're adding at the end to get the whole quotient. You don't have to worry about what's where. So for this problem right here, we're going to start again with the ones place, or I'm so sorry, the largest place. So we're going to see how many times 5 can go into 9, again, without going over. So 5 can go into 9 one time, which gives us 9. So if you look on here, we're using 5. So before I do anything else, I'm going to go ahead and write down the number 5. That way, when I'm like, what did I multiply by to get to 5? That's what I'm writing over here. I already have it here. So 5 times what number got me to 5? Well, it was 1, and that 1 needs to be 100 because this is actually 500 since it's in the hundreds place. So 500 here and 100 there. So we have 500 as our first partial quotient that we are going to subtract away, which leaves us with our 475, just like we did over here. So we have 475 left. That's our new starting point. Just like we had a new box, now we have a new starting point for our division house symbol. So we have 475 divided by 5 now. 5 can't go into 4 because it's bigger, so we can't even take one group out. So we're going to go to 47. We already know that it's 45 from the previous problem. If you look between 45 and 50, which is the next multiple, 50 is larger than 47, so we have to use 45. So we can go ahead and write down 45 so we don't forget that. I think 5 times what is 45? 5 times 9 is 45, so we're going to write our 9 down. And then 1 0 to get us into that tens place means we need to put a 0 over and get our 9 into the tens place as well. So now we have 475 minus 50, which is again going to leave us with 25, which is the same as the second partial quotient on the area model. We got 25, making the partial quotient 90, sorry. So we have 25 left, and 5 goes into 25 5 times. So since it does go even, we're going to go ahead and write our 25 down. It is in the ones place, so we don't have to use any 0 place value holders. So that is 5. We're going to put that there. And then we are going to subtract those 5 groups of 5 away from that 25, giving us no remainder. Love it when there's no remainder. Easy peasy, lemon squeezy. Here's our partial quotients. Since we have nothing down here, we're ready to add. So just add them up, and we have 195. From there, check with your estimate, make sure it's close. Yes, it is. Check your work using multiplication or inverse operations. There you go. It works because we took our quotient, multiplied it by our divisor, and then we got our dividend in the end. So we are, yay, super happy. thank you for tuning in. I know it's probably a weird, long, awkward video. It's been a very long day. I've been talking a lot. I'm so tired, but I wanted to at least get this video out just because I know there's been a lot of questions about how we do math in 4th grade. So these are 2 options. Do what you will with them. I'm gonna try to start making better videos so that I can start posting more often and getting you guys the help that you need at home that we don't always get to in class, or we get rushed through sometimes, or sometimes we just need that repetitiveness. So don't worry about the quiz tomorrow because we're gonna be getting a lot of practice before we take the quiz, and we're gonna keep practicing after that too. So bye guys, see you tomorrow. Thanks for tuning in. Bye.